Based on the absorption of the material that the gamma rays went through, those estimated gamma rays were centered. It's a centroid energy of the vicinity of 90 kilovolts. Induced radioactivity is this experiment was the one which I think convinced me that there was something to all this. You might argue for all the other experiments you've got, maybe tritium contamination, you can't measure temperature right, you can't do this, you can't do that. But Kevin Wolf had been studying neutron emission. He came to SRI at the encouragement of Everett, because his electrochemistry was very similar to Mike McCoubrey's at SRI. McCoubrey explained to him that he could put a surface colloid on by adding boron and silicates to coat the surface, which would allow the deuterium to go in, but inhibits gas formation on the way out to get higher loading. And he went back and he tried that, and during one of his runs, 3 of his cathodes became radioactive. The radioactivity was verified in a high purity, high efficiency germanium detector at Lawrence Livermore Laboratory. It was Kevin Wolf, who is not with us these days. This was a tremendously important experiment. Kevin was unable to replicate this experiment. I personally essayed more than 100 cathodes from different people's experiments looking for this gamma ray spectrum, and came up empty-handed. The identification of the isotopes goes as follows. There were roughly 100 gamma lines observed at 4 orders of magnitude above background. These isotopes were identified from the gamma lines, but it was preliminary identification. I think one of them was wrong. The half-life of these isotopes ranges from about 3.5 days, there's one at 4.3 days, up to several years. The amount of isotopes, Kevin had a record. He could see in the gamma rejection of the neutron detector when the radioactivity was induced, and he could work back to t=0 from a measurement of the amounts at different times, how much was the initial hit. And these are the numbers that he and his collaborator at Berkeley came up with. Total induced radioactivity corresponded to something like 10 joules of these numbers don't look like 10 joules. He was arguing something like 10 joules of induced radioactivity. The excess heat effect, claimed power densities are in the general range of 5 to 5 kilowatts per cubic centimeter. In some cases, it's likely to be a bulk effect. In other cases, likely to be a surface effect. In general, it's not particularly well understood where and how it happens. In the Kevin Wolf radioactivity, the radioactivity was peaked in the middle of the rod and was lower outside the rod, which was suggesting in that case it was a bulk effect. In other cases, it's rather clearly a surface effect. The total energy produced is, in many cases, is reported to be on the order of hundreds of electron volts per palladium nucleus. There are claims very much higher than that as well. The argument for the total amount of energy is such that you would not be able to account for it from a chemical process. The calorimetry, there's been lots of calorimetry done. At SRI, we did closed cell mass flow calorimetry. It's called first principles calorimetry. Probably can't see it, but water flows in, water flows out. The water flows all around the cell, and any energy from the cell goes into the water and can be detected through a knowledge of mass flow rate, the heat capacity, and the temperature difference, which is measured accurately. The SRI group was able to account for their best calorimetry, roughly 98.5 to 99% of the energy from things going on inside. The amount that they could not account for first principles calorimetry was done with fixed law constant. The highest accuracy reached in this calorimetry is roughly 0.1%. In this data, the solid line is the current steps that are imposed. SRI found that when they changed the current, they would get a response from the cathodes. 2 cathodes were run in identical cells, one light water, one heavy water. The heavy water one went up connection with the current light water one either didn't or didn't as much, depending on your point of view. And there are at SRI something in the neighborhood of 40 different examples of this kind of effect done in high accuracy closed cell calorimetry. There are many examples from other laboratories as well. There are many. The key experimental claims are low-level DD fusion, emission of non-fusion ejecta. There are a number of claims of transmutation. There's a recent paper in Japanese Journal of Applied Physics by Iwamura claiming a transmutation effect that was witnessed in real time, and which is, that effect is consistent with the material I'll be talking about later today. It's induced radioactivity, which even though it's not been seen since, it's not consistent with neutron activation, proton activation, alpha, or other particle bombardment. It's largest in the middle as opposed to the outside. It is consistent. Induced radioactivity, I attempted to model it, and I can model with the approach that I'm doing and get the induced spectral radioactive particles pretty much within a factor of 2 for all except for 1. And the 1 may be a misidentification. NRL does not. NRL looked at it and didn't agree with the Wolf-Berkeley analysis on one of the isotopes. So excess heat effect. Helium has been observed in correlation with the excess energy. They measure the amount of energy, amount of helium, divide, and they come up with a reaction Q value. The reaction Q value has been measured now in 6 different experiments. The best of the experiments gives a value of about 24 MeV, which is the DV go to helium-4 reaction energy, to within about 10%. And tritium production has been claimed to have been observed in many times. Most recently, in a Fusion Science and Technology article, where the tritium was made from inside a hollowed out cathode and black in it. Tritium diffused out of the cathode, decayed to helium-3, it left helium-3, and the helium-3 pattern shows a diffusion pattern out of the center vacant region. Talk about theoretical notions. Postulate. First theoretical postulate. Whatever is going on, DV fusion is at most a minor contribution to it. Namely, in 1989, the claim was that whatever was happening had to be DD fusion, didn't agree with DD fusion, and hence it wasn't real. Let me revise the postulate and say whatever it is that's happening, the primary effect is not DV fusion, at least as known by the nuclear physics community. Another postulate, which I owe to a number of my colleagues, is that in the end, whatever it is that might be going on has to look to be simple retrospectively, because if it isn't simple, it's wrong. Okay, where to start? Fleischmann's initial conjecture, before much was known about this at all, was that 2Ds were going to make helium-4, and 24 MeV was coming out in the form of heat. And at this point, the experiments appear to support this conjecture, although Fleischmann at the time just had no way of knowing. Now, from an atomic physics viewpoint, to get 2Ds to go to make helium-4, your microscopic angular momentum isn't right. You have to have an exchange of 2 units of angular momentum to make this work. So if there's any chance of this to work, you have to supply the angular momentum microscopically from somewhere. Normally in the vacuum, the angular momentum comes from emission of quadrupole electromagnetic quanta gamma ray. The conjecture here is that, the important conjecture here is that if you exchange a phonon can contribute angular momentum. And as a result, this appears to be a place to start, to imagine that 2 deuterons can fuse in a solid in combination with phonon exchange.